Object-oriented programming is a way for you to create your own objects inside of scripts. And to show you how this works, we're going to be creating an object-oriented sword today. So let's go ahead and start by inserting a module script into replicated storage. If you have not learned module scripts before, go ahead and click the video in the top right corner. It's going to walk you through how to use the basics of module scripts. Now first, let's go ahead and rename our table. Remember, a module script is essentially just a table. So to keep things organized, let's name our table sword. And we're going to have to return sword as well, because that's what our table is called. So I'm going to go ahead and write some code, and I'll have you write it as well, and then I'll explain what it does so that you can learn it. So the first thing I want you to write is sword.___ index equals to sword. And I know that probably makes zero sense, but hopefully it will in just a minute. The next thing we can do is say function sword.new. Okay, and this is going to create a new function under the .new name. Now we're going to actually create our sword, so what we can do is write local self equals to set metatable. Go ahead and type 2 squirrely brackets, that's an empty table, and then type a comma and write sword. So make sure your lines of code look exactly like this. And then let's just go ahead and write return self. Okay, now that you have your base code set in place, I'm going to go ahead and try my best to explain what this does. Object-oriented programming uses something called a metatable. I'm going to try to illustrate this as best as I can. Let's say you have a table, and this table has the values square, circle, and triangle. So this is your table. This table holds a square, a circle, and a triangle. But let's say we went ahead and we attached a new table to this. What we're going to do is we're going to attach a metatable to this table. And let's say this metatable has diamond, star, and oval. So you may be asking, what on earth is a metatable? Well, a metatable is basically another table that you can attach to a second table that has some different functions attached to it. So right here we've created a table with square, circle, and triangle. And what we're doing is we are setting the metatable of that table. You can think of that as kind of like the parent table. So what we're doing is we're saying, hey, this table, your new parent or your metatable is going to be this green table right here. That's what this set metatable line is doing. It's taking this new table right here, and it is setting sword, remember that's our entire module script, it is setting our sword table to be the metatable of this new table. So now self is this table with sword attached to it as a metatable. Okay, great, but how does that actually work? Well, remember, this right here is self. We have our regular table, but we also have attached to it a green metatable. And metatables come with what are called meta methods. Meta methods are basically specific actions that Roblox has created for metatables. For instance, we are using the index meta method, and that is the ___ index. So within metatables, you can set the index of that metatable to another table. And what does that do? Well, let's say that we wanted to find a certain key inside of our original table that doesn't exist. And if this doesn't make sense, just bear with me for a second. Let's say we wanted to find self.$. Remember, this is self right here. And let's say that we wanted to try and print self.$. Well, you're going to recognize there is no key of $sign inside of our red table. But because we have a metatable attached to this red table, it's going to take in the index. So if we ever look for something like this, self.$, and it just does not exist in our red table, well, it's going to jump to our metatable, and it's going to find whatever table we set to its index. And it'll search through that table to see if it could find a $sign. Now, how is this useful? Well, usually in object-oriented programming, we will set the index of the table to the entire table itself. So for example, right here, we would set the index back equal to this table right here. And now this may seem confusing, but just follow along here. So if we were to look for self.star, again, it does not exist in the red table. So it's going to go to the metatable and find the indexed table. In this case, we've set the index table back to itself. So we're going to look to see if we can find star in this table, and oh look, we found it. So we are going to push it all the way back, and so now we can access star from this self variable. So by setting the index of sword to itself, what we're saying is whenever we make a metatable out of this table, it's going to look inside of itself to find any missing methods. So let's use this practically. Let's say sword.name, and then let's set a string. We can say equals wood sword. Now this self variable, if we were to print self.name, it should print wood sword. I renamed my module script to sword modules and totally forgot we have to load that module script. So insert a script into server script service, and we'll just say local module equals to require game.replicated storage.sword modules, and then we can just say module.new because it's going to run that new function. Now if we run it, you're going to see it prints wood sword. However, if we were to just print self, what may confuse you is we have an empty table. So remember, self is just this first table that we put in the set metatable function. But it also has a metatable attached to it, and that is the sword. And because we have set the sword index to sword, whenever we reference self, so for example, if we were to try to print self.name, first it's going to look into this table and it's going to say, hey, I don't have anything called name. So now let's check our metatable. Have we set an index? Well, we sure have. What is that index? It is sword. So now let's go ahead and look inside of the sword table to see if .name exists. And look at that, sword.name does exist. So we're going to be able to access sword.name even under this self table. So that's how we're able to get self.name. Hopefully that's making sense so far. Now let's go ahead and create a function that we can attach to our objects. For example, let's go ahead and create a sword swing function. We can say function sword.swing. And then let's just go ahead and print swing. Okay, so next, let's go ahead and inside of the sword.new function, let's just go ahead and run self.swing. Again, remember, since we say .swing, it's going to check for this table, but because .swing does not exist in that table, it's going to look inside of sword's index, which is sword. So it's going to look through everything inside of the sword table, which we've added sword.swing to the table. So it's just going to call that function. And now we can go ahead and hit run, and it's going to go ahead and print swing. Now if we remove this line, what we can actually do is we can run this through the script. So if we go back to our server script, what we can do is we can say local self equals to module.new. And remember, because we returned self, we already returned back our metatable. So if you were to go ahead and print self and put this there, we would have the same result of it printing an empty table. But that means we can also write self.swing and call that swing function. So if we go ahead and run it, we have the same effect here of it printing swing. Now to illustrate that real quickly, let's go ahead and take our tables from earlier. Now instead of using shapes, I'll show you exactly how it's working in our script. Remember, we created an empty table and we set its metatable to our sword table. Now inside of that sword table, we have a swing function. And we set our index back to our sword table. Now remember, this is self. It's our regular table with a metatable attached to it. And because we have set our index of the metatable, if we're missing a value such as the swing function, and we call self.swing, it's going to look into the index and it's going to find that the index is our sword table, and it's going to call this function here. That's what's happening. And when we returned self, we basically just sent all of this back up to our regular script so we can access all of this from that script. So let's go ahead and customize this a little bit more. Remember, just like you can add to a regular table by saying something such as sword.name equals to basic sword, and this will add the name key to our sword table, you can do the same with our self metatable. So we can say self.name equals to, and let's make this a stone sword. And let's go ahead and set its damage. We can say self.damage equals to 500. And then we can say self.swings equals to 10. Let's just say they can only have 10 swings and then the sword breaks. So all these new values, damage, swings, and name, have been added to this table right here. So now if we're to print self and run it, you'll notice it'll print this table right here that has the damage, the name, and the swings, because we added this all to that table right there. But once again, we can also access anything inside of this sword table because we set the meta table to that sword table and we set the index properly. Again, if it's not making sense, just come back to this little chart right here. Hopefully that helps. Inside of our swing function, let's say we wanted to reduce the swings by 1 every single time. Now we could pass self as a parameter, but there's a much better way to do this. Instead of using a dot on the swing, we can use a colon, and now we do not have to pass in the self. It just already has self attached to it. And you may be wondering, how does this work? Well, basically by adding the colon, we're telling Roblox that this is a metatable function in which we have self. Let's go ahead and illustrate this again. Remember, this is our self. It's our table with our metatable attached to it. So by writing colons here instead of a dot, what it's basically telling Roblox is, hey, this is part of a metatable function. And so whenever I write self, I am talking about myself. And this self has access to the damage, the number of swings, the sword name, and because we've set the index, it has access to everything else that is inside of our sword metatable. So, when creating a function, we can tell the script to modify something in self, which will go right back to this table here. So keeping that illustration in mind, if we were to say self.swings minus equals 1, it's going to go back to itself. Remember, that's this metatable right here that we created, and it's going to find swings inside of that table, and it's going to remove 1 from it. So, if we were to go ahead and run this function, self.swing, and then we print self.swings, and then let's go ahead and print self.swings beforehand as well. And let's just do this a bunch of times. So we're going to print our swings, then we're going to swing, and then we're going to print our swings, and so on and so forth. So if we run it, I almost forgot, we changed it from a dot to a colon, so go ahead and make sure that all of these are colon swings and not a dot. Otherwise, we won't be able to have access to self. So now if we go ahead and click run, you can see it counts down from 10 all the way to 6 because we're printing the amount of swings and then we're swinging and then we're printing the amount of swings. And remember, this swing function is going to lower the amount of swings inside of that object every time. Again, let's go back to the whiteboard. Let's say we have 10 swings inside of our self, which is our sword object. Well, whenever we call the swing object, we basically say self.swings minus equals 1. And remember, this self goes all the way back to the original table and it looks for swings and it's changing this to 9. And then it's going to change it to 8 the next time we call it. And so on and so forth. We can create other functions inside of it as well. Let's say we wanted a block function. We can say sword colon block. And inside of that function, we can just print blocking. Now, obviously, you'd want to put your block logic in here, but we can, instead of swinging all these times, we can say self colon block. And if we go ahead and run, we can see blocking because we called our block function that was attached to our object. Now, what's really cool about object-oriented programming is it creates a brand new object every time you call this new function. Remember, that's because we're creating a new metatable every single time we call it, and we are returning back that new metatable. So we could create as many swords as we want to. Let's rename this self to sword, And then we can say local sword2 equals module.new, local sword3 equals to module.new. And now we have all these different swords that we can play with. So we can swing the first sword and we can block with the second sword. Now that's cool, but what if we wanted to go ahead and change the values based on our sword? Let's say we wanted one of them to be a stone sword and one of them to be a wood sword. Well, we can pass parameters into our new function. So here, let's just go ahead and pass in a name, and that'll be a string. And then we'll also pass in a damage, and that'll be a number. And so instead of setting the name to stone sword every time, we can set the name to name, and then we can set the damage to damage. And then let's say that we had an enemy. I don't know what our enemy would be, but let's just say we had an enemy equals to workspace dot. I'm going to create an NPC real quick. Okay, I've created an enemy, and we'll just say the enemy is workspace.enemy. So instead of that swing function, let's just go ahead and say enemy.humanoid, take damage. How much damage do we want to take? Well, we'll take whatever the damage is. So we can say self.damage. Remember, using the self is going to go back to the original metatable, and it's going to check for the amount of damage for that sword. Okay, so now that we have the name and the damage parameters, we're going to need to pass them through whenever we call this new function. So let's say this first sword we're going to make is the wood sword with a damage of 10. And the second sword is a stone sword with a damage of 25. And finally, we can make a gold sword with a damage of 50. So now we have all these different swords. And let's just go ahead and say sword 2 swing and sword 3 swing. So remember, that's 25 damage and that's 50 damage. So it should do 25 damage to the NPC and then it should do 50. To see if this is working, let's go ahead and add some waits. So it's going to wait 3 seconds before doing it. Alright, let's go ahead and check it. So if we come to the enemy, we can see, yep, it's done 25 damage and it should go all the way down to here as it does 50 more. There we go. So that is object-oriented programming. If you have any questions, feel free to leave them down in the comments. This is such a complex and confusing topic for many, and I tried my best to break it down, but I know it still can be confusing, so please let me know if you have any questions. And if you want to learn how to use collection service to organize your scripts even further, go ahead and click the video on screen now. I think you're going to like it.